Hey YouTube. So I thought I'd put on a bit of a more vlog-styled video for this one. I've already removed the plates here, and as you can see, it's just what I did was I've got a piece of tin foil here that I folded and I've slotted down the length. I got it folded on the end here so I could tape connections to it and then seal this up. I don't have to tape connections. I made holes. I've just been putting tape. But because this end, I mean, yes, charge can be lost from it, but it's not the primary end where charge wants to escape from. Where the real problem is over here. And so I've been trying to rectify this issue for a while. Down around, coming around here, down this surface, and actually because of a design decision I risked over here, I tend to lose quite a lot of charge. And so I need to seal this better. And every time I put tape, I get arcing out a different place. Every time something like that happens, nothing really rectifies that. I surrounded my bars in PLA thinking, oh, well, you know, maybe it's better than the electrical tape. And the balance is, but the actual bars are not. The electricity just arcs right through it. It's such a high voltage that it comes out. So what exactly is happening here when the electricity is arcing out like that? And to solve this issue, I'm gonna put some clear acrylic nail polish onto, well, I'm told it's supposed to be acrylic. It doesn't say acrylic anywhere on it, but what else would it be? So I'm going to put this nail polish on, and I get, I think it's like 1,500 volts for every mil of thickness that I put of this on there. So one way or another, it is going to seal this up a lot better, and I'm going to build a lot more voltage. But what is going on when I'm getting arcing out through there? And essentially, what's going on is the charge that's built up in these plates becomes so intense, so incredibly intense, that it starts tearing electrons away from the surrounding air. And oh yeah, this is acrylic nail polish. I'd recognize that smell. I'll have to thank my wife for sacrificing her nail polish. I didn't steal it, she gave it to me. So, yeah, I'm gonna get quite a bit more voltage here. But anyway, the what's going on is the electrons are being torn away from the air molecules, or conversely, on the opposite plate, electrons are being forced onto the air molecules, and they don't want to be there. So, and now you have these plates that are oppositely charged. They're very close by. The diameter of those rods that are passing by, it's only 13 millimeters, I should say. So with a 13 mil plate like that, you start plugging the math in, and you find out that that kind of you know, especially as a cathode to a big plate like this, you know, you could create an arc of quite some distance at a much lower voltage than what you would expect. It doesn't want to stick too well. Either that or I'm not recognizing the spots where it's drying. But so what we need to do is, or what I need to do, not what we need to do, I'm the one doing it, need to have a good solid seal here. And it'll still ionize the air, but they won't have anywhere to go. The big important thing is that there is no space for these electrons to travel. They need to be forced to go in the direction that we want them to go in, or at least I want them to go in. And that's the trick with these machines. It's at the end of the day, what you're trying to do is you're trying to set up the conditions to get electrons to move where they already want to go, and to have the conditions set up well enough that where they want to go is useful to you. The way that I'm going to accomplish that is I'm going to use some power conditioning. I'm going to use some power conditioning, and I'm going to see about getting my charge built up in my capacitors to go to a much higher level. Oh yeah, that'll be a nice little layer there. Now, how hard is it to block the path for an electron? Well, very hard, apparently. I mean, they're tiny. They can basically go wherever they want. Okay, yeah, some materials have a resistance rating and they're not considered conductors, but let's be honest here, right? Like, that doesn't mean they don't conduct, it just means they conduct very poorly. Everything conducts electricity to some level. There's pretty much nothing that's a super resistor where it's got an infinite resistance. That's unheard of. And if they ever figure that out, let me know, because I want to make capacitors out of that. But anyway, I think that'll be all for now, YouTube. These fumes are pretty intense, so see you later.